Tonight is day 4, week 12. Again, excuse me. Again, that's day 4, week 12 of our journey together. And so let's get right into it. Remember to have something to write on, have something to write with, and that as you are doing the questions, please send me a picture of them so that I can see that if you're doing them correctly. All right, so let's begin with the homework that was given to my Bgcse students. We're going to start off with that. And then we're going to do the homework that was given to the Bgcse ones after. All right, so let's dive in. Let me see. It was this homework. All right, so let's begin with this question. We're going to do it by hand. All right, so the question states the following: evaluate and then express your answer in simplest form. All right, evaluate and then express your answer in simplest form. So we will simplify it. You all can hear me?
Yes, sir.
Okay. All right, so let's get right into it. Okay, so we have 2 over 3 multiplied by 4, which is the whole number, and 1 over 4. And we're going to subtract it by 1 and 1 over 6. Alright, can someone tell me what you think is the first thing to be done? It's solving this question. What's the first thing to be done?
Turn mixed fractions into improper fractions.
Yes, definitely. So we have 4 and 1 over 4.
Yeah, that's 17 over 4.
We want to change that into improper fraction. So let's do that. We got an answer already, which says 70 over 4, but let's see if that's correct. So 2 over 3 multiplied by 4 times 4. So we multiply the 4 and the 4, and then we add 1. So 4 times 4 is definitely 16, plus 1 is 17. Right, so this is 17 over 4 minus, we can also change this into an improper fraction. What we get?
7 over 6.
7 over 6. Well, 1 times 6 is 6, plus 1 is 7. So that's 7 over 6. Again, that's 7 over 6. It's going to be equal to, right? Okay, so what can we do? We're going to multiply, right? So we can multiply this 2 with the 17. What is 2 times 17? Anyone? What is 2 times? Say it again. I can't hear you. 34. So we multiply the 2 by the 17 to give us 34. And we multiply the 3 by the 4 to give us what? 12.
12.
And so we have minus 7 over 6. Okay. All right. Now here we need to find the lowest common multiple between 12 and 6, which is what?
6.
Mm-mm. Lowest common multiple between
2.
12 and 6.
2.
2.
No, sir. Lowest common multiple
2.
between 12 and 6.
12.
12. 12. The lowest common multiple between 12 and 6 is 12.
Yes.
So 12 would be our denominator. And we ask ourselves, what times 12 gives us 12? What times 12 gives us 12? Anyone?
1.
1. Same thing here, 34. Whatever we do to the bottom, we must do the top, so we have to multiply that by 1. So 1 times 34 is definitely 34 minus. What times 6 gives us 12?
2.
2, very good. Whatever we do to the bottom, we must do to the top. What is 7 times 2?
14.
14. So now we have 34 minus 14. What is 34 minus 14?
20.
20, very good. So it's 20 over 12. So the answer is 20 over 12. But are we done?
Can simplify.
Yeah, they say in simplest form. So we have to simplify. What number goes into both 20 and 12?
2.
Let's do 4.
2. 44.
What is 20 divided by 4?
5.
What is 20 divided?
5.
Yes, 5. And what is 12 divided by 4?
3.
3. So we left with 5 over 3. And we can write 5 over 3 as a...
No, I mean next one.
We have 5 over 3. 5 over 3. And what's 5 over 3? It's going to be... 5 goes in itself. 5. 3 goes into 5 once. Alright. 5 minus 3 is 2. So that means we have 1
And 2 over 3.
and 2 over 3. Alright, and that's how we would do that. Any questions?
Yes, sir.
Oh, okay. Alright, so copy that down for me and send me the correct working. Let me see. Ask them to join first. One moment. So take this question out for me. Any questions on how we got 1 and 2 over 3? Hello?
What'd you say?
Any questions on how we got 1 and 2 over 3?
No, sir.
Okay. All right, so let's move. Okay, so let's go to this question. I saw two persons sending their work for this one, and all two of them got it right. So that's a good thing. The only thing is that for one of them, they in their the very last step they was not supposed to change um it's not supposed to change that I think it was a negative x or something like that. They wasn't supposed to change it. They switched it. They should have leave it just like that. Um, I hope they know what I'm talking about. But they got it all right until that last part. Um, one of them got it completely right, and then the other one got it all right except for one last step. The very last step should be omitted, and then it will be right. Anyway, we know who they are.
Are you meaning me?
Yeah,
What last step?
the last step you shouldn't have switched them. You shouldn't switch the numerators. The terms in the numerator you shouldn't switch them
Oh, I get what you're saying.
because when you switch them, you change something to a negative that was never negative.
Oh,
You understand what I'm saying?
oh, yeah, I understand.
Yeah, but everything
Okay.
else is right.
Well, at least I get to work in then.
Yeah. That's good. You surprised me. I look at that cafe, say, wait. This right? Check it again. Wait, this right? Yeah, that's right. That's good. Uh, okay, so here we have 5 and x plus 3 minus 2 and x minus 1. So the idea is to have the same denominator. Okay, the idea is to have the same denominator. So the lowest common multiple between these two denominators. So the lowest common multiple between these two is going to be equal to x plus 3, x minus 1, x plus 3 and x minus 1. So that's what's going to be our common denominator, x plus 3 and x minus 1. That's what we're going to make um, the common denominator, x plus 3 and x minus 1. Now, so we ask ourselves, right? What times x minus 1, right, is going to give us x plus, sorry, is going to give us, what times x minus 1 is going to give us x plus 3 and x minus 1? That's the question. Okay? What times x minus 1 is going to give us x plus 3, x minus 1?
SPT, you have to use a calculator for this, or you can just.
No, strictly by hand. Okay, go ahead. What times x minus 1 is going to give us x plus 3? X minus 1. Hello?
Do you mean the 5 times the x minus 1? Right there?
No. I'm asking, what times x minus 1 is going to give us x plus 3 times x minus 1? Notice we already have this factor. What is the missing one that we don't have? We already have, let's look at this one, x minus 1. For this denominator, we only have 1. We only have x minus 1. What we need is x plus 3. Alright? And so that means that we have to multiply.
Hold on, Mr. T, what you say just now?
What I'm saying is, okay, let me do something. Okay, so what I'm saying is if we look carefully at this one, x minus 1, right? What is missing from x minus 1 to give us x plus 3, x minus 1? Or to be equal to our lowest common multiple? Well, we already have x minus 1. The only thing we need is what?
X plus 2.
X plus 3. Okay, so that means that we have to
What you
multiply.
mean for the denominator?
For the denominator, yes. So that means that we're going to multiply this denominator by x plus 3. So we already have x minus 1 already. We need x plus 3.
Mr. T, I confused. I'm X plus 2 already there.
X plus 3 is for the 5 over x plus 3. It's not for this one.
Oh, okay.
Yeah. Now, whatever we do to the bottom, we must do to the top. So we're going to multiply that by x plus 3. Alright, similarly, we have x plus 3. What are we missing?
X minus 1.
X minus 1. Very good. So you're going to multiply this side by x minus 1.
That's the thing for multiplication with red dot.
Yeah, that dot means multiplication. And so it's going to be x minus 1. Good. So now, for our denominators, we have x minus 1 and x plus 3, which is right here. For our numerators, we're going to take 5 and multiply this by that. We're going to take 2 and multiply it by this. Alright, so that's what we're going to do. Alright, so let's go. So we're going to take 5 and multiply it by x minus 5. So we're going to take 5 multiplied by x minus 1. So that's 5, open bracket, x minus 1. Minus 2, open bracket, x plus 3. And so that's what this is equal to. Moving on along, we say what is 5 times x? What is 5 times x?
5x.
5x. What is 5 times minus 1?
Negative 5.
Negative 5. What is 2 times x?
2x.
2x, very good. And what is negative 2 times 3?
Negative 6.
Negative
Negative.
6. Very good, all over. X plus 3. X minus 1. X minus 1. Alright, so now we have to group the like terms. So we have 5x and 2x together that we could group. So it's going to be equal to 5x minus 2x. And we have negative 5 and negative 6. It's negative 5 and negative 6. All divided by x plus 3.
X plus 3 times x plus.
Times x minus 1. And that equals to, what is 5x minus 2x?
3x.
3x, yes. And what is negative 5 minus 6?
11. Negative 11.
Sorry about that. Divided by, sorry, divided by,
So we continue going down, or you just go to cross?
I just gone across now, x plus, oh, yeah, in your one, you could continue going down. X plus 3 and x minus 1. Right, and this is the correct answer to the question.
Basically, when you was talking about the negative thing, what you was meaning?
Oh, the person ended up switching these two. And when they switched them, they did negative 3x plus 11. That's wrong. It's be 3x
Oh,
minus 11, yeah. So up until here it's fine. We can move on to allow this person to join. Alright. 3x minus 11 divided by x plus 3, x plus 1. Sorry, x minus 1, sorry.
Excuse me, Mr. PT.
Yes, sir.
Yesterday, right? It seemed like the stuff we was doing yesterday. It was on my mock exam.
You
For
serious?
yeah, for
Wow.
page 2. Yeah, I say, oh yeah, now I remember this.
Wow. That's amazing. Wow, that's amazing. God is with us.
Mr. T, do we still get points if our working is correct, but the answers are incorrect? Incorrect.
Yeah, certainly, yeah. Get some points. You get some marks. Alright, so let me know when I can move this. All right, let me know when I can move it, please. I can move it now?
Yes, sir.
All right. Okay, so moving right along. Okay, so let's continue. So we already did number 12. Let's go on to number 11. We already did number 11 with the perimeter and stuff like that. All right, so let's go on to number 8. Wheat. Oh no, it's number before that. Number 8. It should be pretty easy. Four points though. Wonder why. A machine can print 25 labels on an envelope every minute. Calculate the number of labels that can be printed in 2 hours. A machine can print 25 labels on an envelope every minute. Calculate the number of labels that can be printed in 2 hours. How will we go about doing that?
We will find out how many minutes in 2 hours.
Yeah, how many minutes in 2 hours? I like that idea. So 2 hours is going to be equal to how many minutes? That's pretty easy. So 2 hours,
120.
120, because 2 hours is equal to 1 hour plus 1 hour. And we know that 1 hour is how much minutes?
60.
60 minutes. So 60 plus 60.
120.
120, yes. 60 minutes plus 60 minutes equals to 120 minutes. Alright, so that's what we have there. 120 minutes. So what it takes, every minute, 25 labels is gonna be produced. So how in the world are we gonna get how much is produced in 2 hours? How would we do that?
Would it be 120
Multiply.
multiplied by 25?
Say it again.
120 times 25?
Very good. So it's gonna be 120 multiplied by 25 labels. It's gonna be 25. Reason why is because every minute we get um 25 um, labels, and so that means that in 2 minutes we'll get 50. In 3 minutes we'll get 25 times 3. In 4 minutes we'll get 25 times 4, all the way up to 125 minutes, which will give us 25 times.
I got 3,000.
Say it again.
I got 3,000.
You got 3,000 flat.
Yes, sir.
All right, so let's actually do it right on. So 120 times 25. 5 times 0 is 0.
Yeah.
5 times 2 is 10. Put the 0 down. Put the 1 up. 5 times 1 is 5, plus 1 is 6. You should put the 0 as a placeholder. 2 times 0 is 0. 2 times 2 is 4. And 2 times 1 is 2 times 1 is 2. So we add in these two, we get 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 6 is
6 plus 4.
sorry, 6 plus 4, my bad. 6 plus 4 is 10. And 2 plus 1 is 3. So that means that it's going to be 3,000 labels produced in 2 hours. Wow, that's a lot. Alright, so that's how you do it. You multiply 25 by 120 to give us our answer. Alright, let me know when I can move it. Alright, let me know when I can move it.
You can move it.
Alright, thank you. And we're moving right along. Okay, so let's go ahead and factorize. Factorize completely, that's the next question on the agenda. Factorize completely. So I'm going to give you a few moments to do this. Try it on your own, probably like 2 minutes to do it. And let me know what you get. I'm right there. I ain't going nowhere. But try it on your own first before I actually do it. Alright, and once you have submitted, done it, take a picture of it and send it to me quickly so I can see what you have done.
Mr. Bussy, this question comes from Bgcse.
Not Bgcse. Alright, so can we try it now? What did we get? What did we get? Hello?
Still working.
Still working. Alright. Alright, so let's do it. So here we're gonna use factorization by grouping. So we have p squared minus p q minus p r plus qr. So the idea here is that we're gonna group these and factorize one by one. So you're gonna factorize this section and then we're gonna separate this section. Factorize that section. So the question is, what is common in p squared and p cubed? What term is
P.
common? Yes.
They both have P.
Yeah, they both have p, right? So I'm gonna pull out a p. here, open bracket, we'll be left with what? What times p gives me p squared? What times p gives me p squared?
What?
Not p. Someone said it already.
Me?
Because p times p is p squared. Minus. What times p gives me pq?
What'd you say?
What times p gives me pq?
Q.
Q. Very good. Alright, so that's that side. Now we need the other side. What is common in PR and QR?
R.
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 Very good, R. And so it's gonna be R open bracket. What times R gives me PR?
R.
What times R gives me PR?
P.
P.
P, very good. And then this is gonna be minus because a minus and a minus gives me positive. So R times what?
Q.
R times Q. Alright, so next up, it's gonna be equal to, remember that this is the same thing as that, right? So we could bring them together. They're the same thing, we could pull that out.
But see, well, you could go back to the step you did to put that Q there.
Alright. What is R times P? What is R times P?
P.
PR. Right? R times P is PR. What is R
So
times Q?
QR.
QR. Okay, that's how we get it. So P minus Q here, P minus Q is here. We're gonna factor out the P minus Q. And then we are left with simply P minus R. Alright, and so that's how we factorize. Alright, so that's how we factorize. It's called factorization by grouping.
Mr. D.
That's all.
We don't mind explaining that last one real quick, please.
You mean how I pull out the P minus Q?
Yeah.
Yeah, okay, they are common terms. So this is common in both. Alright? So since they're common in both, we could pull out that common factor. And once we pull out the common factor, we just left with P minus Q, which is that. Then we just have what's left. P minus R.
Mr. Bd.
Yeah, go ahead.
So the common factor is P then?
No, not P. The common factor is P minus Q. That's why it's in this term. This whole thing is common with this. So we're able to pull that whole term out. And then we just write down what we're left with in the next bracket. P minus R. Make sense? Or still fuzzy? That's a question. Make sense or still fuzzy?
I gotta check it on my own later on.
Okay. Okay. Wow. Just remember to treat P minus Q as a as common terms. So for example, if we had x squared, right? let's say we had xp minus xh, right? We could pull out the x, right? So we just have x open bracket. What's left? P minus what?
H.
H.
Yeah, that's the exact thing. That's the exact thing we'll be doing. The only thing now is instead of x, we have p minus q, which is the common term in both. So we're able to pull that out, and we're left with whatever is left. In this case, it was p minus h. In this case, it's p minus r. Okay. All right. So let's go. All right. So let's move on to question number 9. Hopefully something more simple or more familiar. This is profit versus loss. Calculating profit. So profit will be, by definition, what is profit? Anyone know? We say profit.
You say?
Say it again.
The money you make from something.
Yeah, the money you make from something. So you bought some goods, and the money you made from selling those goods, um, minus the expense, is your profit. So try this one, and then tell me what you get when you get the answer. All right, any answers for me?
Not
yet.
I was still writing it.
Any answers yet? Anyone?
So,
Let a profit be 19,000.
You say $19,000?
I think, yeah.
Okay. Anyone else?
Yeah, 19,000.
19,000? How did you get 19,000?
You take away, you subtract how much she bought the house for to how much she sold it for, and then you get the profit.
How much he bought it for?
She bought the house for 95,000, and then she later sold it for $114,000. So
So you
to
subtract
subtract,
those two quantities, right?
yes.
Yeah,
Yeah, that's how you do it.
I got the same thing.
19,000?
Yeah, so
Alright. Okay, so let's actually do it. So remember that she bought the home for $95,000? She probably bought that home in 1996 or something like that. So I'm saying selling for that price, at least decent homes, and selling for that price these days. But then she later sold it for 114,000. So a profit is going to be equal to 114 114,000. 114,000 minus her expenses, or how much she bought it for. It's gonna be 95,000. So that's going to be equal to 114,000 minus Miss Cooper, the reason why we didn't square it is because we're not multiplying them. It's a factorization. We're bringing them
Oh,
together. We didn't mean multiplying them. We're pulling out the common factor. That's the difference. We're multiplying. So 114, 114, 0, 0, minus 95, 0, 0, 0. That's certainly 19,000. So 19,000 is the correct answer. Alright, so let's move on. So next question says calculate the profit as a percentage of the price she paid for it. So calculate the profit as a percentage of the price she paid for it. 2 points. Alright, once again, write it the question down. Alright, so calculate the profit as a percentage of the price she paid for it. Any answers or ways you think we could do it? Any ideas? Go ahead, you don't have to be shy.
multiply.
19,000 over 95,000 times 100.
Why 95,000? Why over 95,000?
That's something she bought it for, right? 95,000.
Yep. So you want the profit divided by the cash price. Or not the cash price, the original price.
Yeah, because the question says how much she paid for it. I mean, she paid for it.
Yep. So it'll be 19,000 divided by 95,000 multiplied by 100. So that's going to be the profit divided by the original price multiplied by 100. So that's the profit written as a percentage of the original price. All right. So let's do that. So it's going to be 19,000. 19,000 is the profit divided by the original price, which is what? 95,000.
5,000.
Multiplied by 100
Over 1.
for 1. Now we do some cancellations. So we have these two cancel with each other. They cancel out and they cancel out. And then we are left with 19 times 100 is 1,900 because you add the zeros in the bottom. All over 95. So what's the result?
20%.
We want the profit, right? So it's 1,000 900 divided by 40 divided by 95 is exactly 20. So 20%. 20%. Any questions on that?
Yeah, let's Bgcse.
Yep. That's why it's so easy, right?
Yes.
Alright, let me know when I can move on, please. Can I move on?
Yes, sir.
Yes, sir.
Alright, let's go. Alright, is anyone trying to join? Kennedy. Kennedy Nuri. Let me take the attendance one time. You know where I'm from? You know where I'm from? Guess.
Oh,
Guess.
Nancy.
Yeah, what happened to class president?
I know you can say that.
Oh my, that would be alright now. Okay, okay, okay. Okay, so alright, so let's consider this one. Okay, so consider this number. It says here express 784 as a product of its prime factors. Alright, so do that for me. 784, break that down as a product of its prime factors. You have 60 seconds. Express 784 as a product of its prime factors. Or you need 1 minute and 30 seconds. Yeah, 1 minute and 30 seconds to do this. Express 784 as a product of its prime factors. Alright, go ahead. Shouldn't be hard. Alright. Any answers from anyone? 784 as a product of primes. Anyone?
I have one second. I know for that.
What is it?
I'm going to tell you the yours.
Alright, so let's go. So we have 784 1 divided by, we want to express it as a product of primes. 12 plus 7. What's 12 plus 7? That's 18, 19. Also incorrect. 784. What could be used to divide that? 9 is single week. 8 works perfectly. So if we break it apart, it's gonna be equal to I get 8 times 8 times 98. Let's break this down further.
Mr. Matilda, how are we supposed to know that 8 times 98 is that?
Well, I started with the highest possible number, so I started with 9, and 9 didn't work, so I tried 8, and 8 just happened to work.
But how you know what time it gets you up?
Because once you divide 784 by 8, it'll give you 98. So you already know that.
Oh,
Yeah, yeah. Right. So is 98 prime? 98 is a prime number. That one makes sense to me. No, it can't be prime because it's even. So
Use it like
it's not a prime.
2 is too small. I don't want to use 2. Looks like 2 is our only option now. Yep, we have to use 2. And if we use 2, it'll be what? 49, right?
49, yeah.
Mm-hmm. Okay, so we home free at this point. What times itself gives you 49?
7.
7, very good.
7.
So that means that 49 is a perfect what?
Prime number?
Perfect
Wait,
square.
no.
And then with 8, it's gonna be 4 times what?
Two.
Yeah. And then we have to break this down still. So this is 2 times 2. Alright, so therefore 784 written as a product of primes is gonna be equal to 1, 2, 3, 4. So we have 4 tools. So that's 2 to the second power times 2 to the second power. Well, we don't have to do that like that. Let's just write it as 2 to the 4th one time. Because it's 4 tools, so 2 to the 4th power. Where's that right? 2 to the 4th power. Because it's 4 tools.
Yes, sir.
And then 7. How much 7s we have?
2.
2. So basically that's going to be what? 7 to the power of
2.
2.
2. Very good.
Is that the index form?
Yes, ma'am.
Okay.
Good. So 1, 2, 3, 4, 1, 2. Yeah, we good.
Mr. Matthew,
Mm-hmm.
like when you draw that tree looking thing,
Mm-hmm.
you have to put 784 is equal to that, or you could just leave that.
Say it again.
When you don't draw your bubbles and stuff, you have to put that thing to the bottom. 784 is equal to 2 to the 4 times 7 times
Yes.
7.
Yes.
Yeah.
For sure. For sure. For sure. Because that's exactly what that's when you finish the question. The question says express 784 as a product of primes. And so this is you doing it right here. You taking 784 and you're expressing it as a product of primes.
Okay.
Okay, so this is very important. This is the meat of the matter. Okay, so we already know 784 is 2 to the 4th power times 7 to the 3rd power. So let me know when I can move on.
I got it.
Got it? Anyone else? Anyone else?
I got it.
Alright, that's good. Alright, so
I got it.
now we know what is 784 784 as the product of primes. The next question that they're asking us to do is find, how would we read this?
Square root of 784.
Square root of 784. So now there's an H word that is used.
Hence,
Hence. Very good. What hence means?
um,
Like therefore.
and since you
Therefore,
already have it,
exactly. So since you already have A, find what? B.
square root of it.
Yeah. So that's what they're telling us. We have to use the information gained in in the first question. Alright, so let's do that. So from the first question, we know that the square root of, from the first question we know that 784 can be expressed as a product of primes. So let's do that. It's going to be equal to, oh, what am I doing? I wrote down the expression.
Wait, you want to do the question.
Yeah. I didn't clip the questioning.
Mr. Petit,
I got my answer.
You got your answer. Oh boy, Kennedy for you. Kennedy for you. The new E. The N to the E to the W to the R to the Y.
Get it right.
Oh boy, funny boy. Alright, this is gonna be equal to the square root of, well, we could write 784 as what? 2 to the 4th power.
2 to the 4 and 7 squared.
7 squared, yeah. So we could write as 2 to the 4th, we could write that as 2 to the 2 times 2 to the 2 times 7 squared. And now we could split it. So it's going to be equal to square root of 2 to the 2 times the square root of 2 to the 2 times the square root of 7 squared. It's going to be equal to cancel out. So it's going to be this, the square root cancel with the square. Square root cancel with the square. Square root cancel with the square. So we are left with what? 2, 2, and 7. So 2 times 2 times 7. It's going to be
7.
28. Oh, 4. Yeah.
times 7. It's going to give us what?
28.
28. Very good. And so 28 is our answer. So 28 times 28 is 784. Alright, so let me know when you get it. Alright, so let me know when to move it.
Not yet.
Alright. Alright, so let's move on. Someone asked me to go back to Conrad. Can I move it?
What's up?
Okay, someone asked me to go back to A, so let me go back to A for them. Alright, so let's move on. Alright, so the next one is here we're gonna solve x. How would we do this? Any ideas coming from?
What did you say?
How do we do this? How we want to solve x? How do we do this? How do we go about doing
Find the LTM price.
No, we don't need to do that.
Put the 5x.
Nope.
So we put the x's together?
Not the first step. First step, very first step.
We find what is x.
I mean, that's what we're trying to do in general. But down the first step. What we need to do. And we have two fractions. Two ratios. What do we do? Let me give y'all some time to think then. Think about it.
Cross multiply.
Very cross multiply. So we're gonna take what and multiply by what?
That'd be 3x.
Okay, So 3 multiplied by the x and then what else?
Equals
5x.
2 times 5x minus 2 times 7.
Okay, very good. So what we do is we cross multiply. Very good observation. Ricardo, once you see something like this should scream out to you cross multiply. So 3 times x is gonna be 3x equals 2 multiplied by 5x minus 7. Alright, so that's multiply it out. So what is 2 times 5x?
10x.
10x.
Yes, 10x. And what is 2 times negative 7?
Negative 14.
Negative 14.
Negative 14 equals to 3x. And what if
Now we get the.
Say it again. Now you what?
Yeah, the like terms.
Very good. Gather like terms. So what goes where and what goes where?
Carry
Get 3x.
Carry that 10x.
Okay, so carry the 3x to the left or to the right?
Get to the left.
Carry to the left, and then the number goes over to the right. Okay, so let's do that.
So, Mr. Petit, we can't move the 10x's, right?
The 10x is already on the right side.
Oh.
Alright, so this is gonna be 10x minus what? 3x.
3x.
Why is it minus all of a sudden?
Is it gone over the equal sign?
Yeah, because it going over the equal sign. Once it go over the equal sign, we change the sign. It's gonna be 14, negative 14, but it's gonna be what on this side?
Positive 14.
Positive 14. What is 10 minus 3?
7x.
7, very good. You're left with 7x is equal
Is
to
equal to
14.
14.
It's gonna be 14. Then we go by divide both sides by
7.
mm-hmm.
X is equal to 2.
For this concept. So x is equal to 14 minus 7. So x is equal to 14 divided by 7, which is what?
X equal to 2.
X equal to 2. Right? So that's how we do it. First cross multiply to get rid of the denominators. Then you gather like terms. You multiply it and you gather like terms. And you solve x. Alright, let me know when I can move. Alright, can I move it?
Hold on.
And she says she's finished.
That's the
Anyone else?
Angel. Yeah, I'm finished.
Alright, that's good. So let's continue. Okay. Oh my. So let's continue with this to this one. Oh no. It's gonna take a while. Let's do number 1. And come back to this one once we finish the other one. Okay, so number 1 says how much for number 1? 2 points? Alright, so with this one you gotta be careful and you gotta think. Okay. So they give us some details with this. This one is fair game for both BJC and the UPS class to be able to answer this one. It says for an isosceles triangle. When we say isosceles triangle, what do we mean?
2 sides equal.
2 sides are equal, more than that, more than the 2 sides being equal. 2 what?
Angles are equal.
Yeah, 2 angles are equal. So 2 sides are equal, and 2 angles are equal for isosceles triangle. So for an isosceles triangle, one of the angles is 66. Calculate the possible values of the other angles. So if you know that one of the values is 66, calculate.
Where's the other one? 66.
Say it again.
Wouldn't another one be 66?
Yeah. That's true. But there's something else to consider, right? Not only can it be 66, there's another thing that it could be. Okay, so there's this one has, at least in my mind, it has 2 cases. The first case is if 66 is the the first case is if 66 is the angle that is on the sides and not the angle in the middle. So if that's the case, it could be generous, as opposed to angle being in the middle, where there's lots of like, okay, let me show what I mean. So there's two criterias. So 66, the angle, one angle, all we know is what one angle is 66. So if we draw, let's call this case 1. So case 1, angle 66, is identical.
Mr. Petit. So how would you know if they're talking about one of the side angles or the middle one?
That's my point. So they say all possible values. So you have to consider all two of the cases. So angle 66 is identical with another angle. So the first case is case number 1. So the first case is when we have it like this, whereby we have this is 66, and because they are isosceles, if one is 66, the other will also be 66. Okay. All right. So if this one is 66, the second one is definitely gonna be 66 as well.
66.
And then the third one is going to be what?
X.
Huh?
The
third one is going to be, let's call it x. X is going to be equal to 180 degrees minus what?
66 plus 66.
66 plus 66. Which equals to
Mr.
what?
Petit, I say axis and you say homicide as well.
So it's going to be equal to 180 minus 66 plus 66.
132.
It's 132. It's going to be equal to what?
48 degrees.
48. So 180 minus 132, 48. So that's the first case, right? So the first case, in case 1, other angles would be the 66, right? And 48. Alright, so that's that one. Now case 2. All right, so
So
then
this,
case. Hello?
wow.
Then case two. Let me know when I can move this because I'm gonna use the next slide.
Don't move it, hold on.
Can I move it?
Yeah, I'm moving now.
All right, good. So like I said, that the next case that we're gonna be looking at is the case wherein the case wherein that 66 is not identical to any other angle. So the first one is when the 66 is identical to or equal with another angle. In that case, the only other angles that we have would be 66 and 48. But now we're dealing with the second case um, where where 66 is not identical with another um, angle. And so let's write that now. So case 2. So a 66 angle 66 is not identical. Is not identical with any other um, angle in the triangle. Alright, so if that's the case, then we have this drawing where 66 must be in the middle. So this must be 66. So if this is 66, we know that this is also isosceles triangle. So if we call this one B, what must we necessarily call the other one?
A or B again?
No, B. They have the same fate. They have the same angle. Okay, so if this is B, this is B, remember? So the question is solve for B. What would be B?
X.
B is equal to
Remember 66 plus B gives us 180. Number 66 plus B plus B equals to 180 degrees. So 66 plus what is B plus B?
2B.
2B, yeah. To be or not to be? And it's going to be 180. And then at this point, we're going to send the 66 over. So it's going to be 2B equals to 180 minus 66. Alright, so what is 180 minus 66?
114.
So
114.
114, sorry. So divide both sides by 2. So b is we're gonna cancel. So b is equal to 144 divided by 2, which is what?
114.
Oh, I say 144. 114.
So
Thank you. One 4 divided by 2. It's gonna be what? What do y'all get?
57.
57. So b is 57. So other angle that it would take on would be 57.
Yeah.
Are we good?
Yes, sir.
Alright. Alright, so alright, good. Let me know when you're taking that down. Alright, so let's go. Are we ready? Then move forward. Hello?
Yes, sir. Yes, sir.
Okay. Okay, so let's go. That was supposed to be a quick question. Alright, so okay, I was looking for the papers.
It's almost 8 o'clock.
Yeah, it's almost 8 o'clock. Well, you know that's our fast one.
I mean, today felt like it took longer to get here. It don't feel like it went by like in a snap of a finger.
Oh, okay. Yeah. It's be like that sometimes. Just gotta push through. Okay, so Henry earned $24,366. Calculate his monthly income.
Divided by 12.
Yeah, divide that amount by 12. But they say calculate his monthly income. I don't understand why that's for 3 points. Let's see if there's any catch to it. His monthly salary. But we know how much he got in a year. It's divided by 12. And so what is that divided by 12? What is that divided by 12? Anyone did it yet? Say it again. Hello? Hello?
2030.
I could barely hear you.
2030 and 50 cents.
2030 and 50 cents.
Yes, sir.
Okay, so no te sale. It's going to be equal to $24,366 divided by divided by
12.
12. Yeah. $24,366 divided by 12. That's 2,030.50. All right, so I think we're good for this question. Now, the next question states that you have to simplify by collecting like terms. So I want you all to try that one. Simplifying by collecting like terms. Simplify by collecting. Simplify by collecting like terms. All right, so how will we do this? How will we collect the like terms? Go ahead. Don't be shy.
Put all the A's together.
Okay, that's one of them. Okay, so what we have to do is we have to collect all our A's and put them together and all our B's and put them together, right?
Yes, sir.
Okay, so do that for me. I come on right back. One moment, go to the restroom. Come right back. All right, so we have 2A. Any answers, by the way? Any answers?
What's that?
Hello?
Oh, sir.
Not yet. Okay. So you grouping all the A's together. So that means that this would go 2A, negative 3A, and positive 4A. All these would be grouped together. So it's this, and that. So it's 2A minus 3a plus 4a. And so we have b and b is going to be equal to what is 2a minus 3a plus 4a?
3A.
3a.
Yes, so
3a plus what is b plus b?
2B.
2b. Alright, so that's the correct answer.
Did you go back to the next question quick enough?
No problem.
You finish.
Alright. Okay, so let's go back here. Alright, let me know when to move it. Let me know when y'all have it. All we did was group them and then simplify. Alright, so the answer is 3a plus 2b. 3a plus 2b. Okay, so alright, so alright, so let's move on. Alright, so let's consider do we have enough time? Yeah, I think we have enough time. Let's consider this question. Number 3. So let's consider question number 3. See what's happening here. Question number 3. You have the instructions. Alright, so where's the further instructions? Alright, so it's gonna be right out. Alright, so the diagram shows 2 lines. Y equals x plus 1. And the other one, y is equal to 1 minus x. So sketch a copy of the diagram and label the graph of each line with its correct equation. So which one? So the first thing we have to do is we have to actually, for you all especially who don't have it written, you have to actually draw this graph, okay, over and they say When you draw it over, label what the equation of these lines are. Okay. So what will be the equation of this one and then this one? All right. So any ideas? Which one would be x plus 1? Which one would be 1 minus x? And what gives it away? What tells you?
What you say?
Which one would be, which one will you label x plus 1? Y is equal to x plus 1. Which one will you label y is equal to 1 minus x?
Well, the negative side would be the minus.
Alright. The answer is correct, but explain some more.
But so you would mark like 1 and then negative.
So what happened is that we're trying to figure out which one is which. So we know that this one is x plus 1. So that means that the slope is going to be positive. So that means that we are climbing, we are ascending, so that means that it's going to be, this one is going to be y is equal to x plus 1. Right, next we have a downward slope. So that's 1 minus x. So that's this one. So y is equal to 1 minus x. So y is equal to 1 minus x. So we already sketched down. Now the only thing is, on your diagram, shade the region for which the following three inequalities are satisfied. So the first one is that y have to be greater than or equal to 0. All that is saying is that we're going to use the positive axis. Alright, so y is greater than or equal to 0. Then we have the second one, y is less than x plus 1. The third one, y is greater than x plus 1. Okay, so alright, so let's do this one. Let's do this one, C. Let's do this one. So this is y is less than or equal to x plus 1.
It's basically you go back first, okay?
No problem. Alright, let me know when I can move it.
It's basically,
Yep. So
so you could have put y equal to x plus 1 on the next side as well.
which one? No. Yeah, we considering the inequality. And we're gonna use test
No, I
points.
mean, wait.
Okay. I mean, if we could have used what?
No, I mean, what the one where I take the diagram is just a graph of two lines, y equals to
Yep.
x plus 1. Like, you see where you have it now, you could have put it on the next side as well.
Oh. You mean this? If I could have put it down below?
No, up top on the next side.
No. This is not the same thing as that. It's this line. So that's the line we're labeling. So now we're gonna use test points. The good thing is that none of these angles touch 0, 0, so they're the good test points. So we know that our test point always is what?
0.
0, 0, which is the origin, or we call the origin or the middle point. So we're using the test point 0, 0, where x is equal to 0 and y is also equal to 0. So y is equal to 0, less than or equal to, well, x is 0 plus 1. So this is going to be 0 is less than or equal to, it's going to be 1. So 0 is less than or equal to 1. Is that true? That 0 is less than or equal to 1?
So,
Say it again.
what you ask?
Is it true that 0 is less than or equal to 1?
Yes.
0 is less than 1.
Wait.
That's true. Alright, so remember we always shade the true region. So 0 is less than 1. Alright, the true region. 0 is less than, sorry. Remember that we was testing this point with respect to this line, so it's only gonna be, it's really all of this, to be honest, all of that. All of this is the answer, because that's where x is less than 1. But they only want us to do it for y is less than or equal to x plus 1. Just so that means that all these shaded parts are not needed. We just need to show support for y is less than x plus 1. Remember, the true side is the one that we shade, and so that'll be this, all of this bottom part. But because we're only considering the top, you only can shade the inside. All right. No, I
Just,
get that. No, nothing.
you just put a dot there.
Say it again. Oh, we're not done. Oh, well, that's true. We have the shaded NA, so that's this one. Just gonna be this side, all of that. All right, so that's the shaded region right there. Now we have
We don't.
y is equal to 1 minus x. That's this one. So it's gonna be all right. So we have to use y is greater than or equal to 1 minus x. That's gonna be our next thing. Y is greater than or equal to 1 minus x. Y is greater than or equal to 1 minus x. So remember the test point. The test point is 0, 0. Alright, so that means that x is 0 and y is 0. So y is greater than or equal to 1 minus 0. 1 minus 0 is 1, greater than equal to 1. So 0 is greater than equal to 1. What's this saying? 0 is greater than equal to 1, but that's false, right? Right?
Yes, sir.
Because how could 0 be greater than 1? All right, so okay, so that means that this is false. Sorry, I supposed to write false. False. FALSC. I mean SE. So that means that the point 0, 0 is the false region. So everything on the other side is going to be the true region. Let me shade the true. That's strange though. It ain't making sense to me. Strange. Why don't we have? Oh, I see, I see, I see. We have to continue. I was trying to figure why. We have to continue with this. So this side is also good. We could also shade this side. All that is shaded too. So all that is shaded as well. With the first, that's with this. Now with this one, we know that the false is where the point 0, 0 lie. So that means that this part is false. And so with respect to this line, this side would be true. So we always shade the true side. So I'll be this. So this side is the true. Alright, so continue now. Alright, so and then finally, so this is the green one. And then finally, y is greater than 0. That's simply that's all of the x-axis above. That's all of this. Let's use purple instead. Alright, so all this have to be shaded because y is greater than 0. Y is bigger than 0. So this just have to be shaded as well. Alright, so on your diagram, shade the region for which the three inequalities are satisfied. Where is the three inequalities satisfied? All three.
What'd you say?
Where is all three satisfied? All three of the equation satisfied?
No one just say.
Say it again. They are three satisfied. They are
Up top?
satisfied right there, isn't it? Here we have the blue line. So here we have the purple line, the red line, and the
Purple.
and the purple. That's where all three of them meet. So
So we drawn all them lines and we shaded in that part as well.
yeah, this is the part that is most important because this is the part that where all the solutions combine. Good.
It's 8 o'clock.
All right, so it's already 8 o'clock. How? Anyway,
I don't know. Ready?
wow. All right, any questions on this? I should probably
This on Bgcse.
um not not to this extent, but yes, they do bring something similar, not to this extent though.
What you mean not to this extent?
You see,
Robin go.
What you mean?
because here they have one, two, three inequalities that you have to ensure it's satisfied, right? I don't see them doing that for Bgcse. Anyway, do we understand how we got the shaded region?
Yes, sir.
Yep. You sure? Remember we used the test point.
I probably understand it, but I don't.
Would you say, Miss Cooper?
So
I
confused.
understand that part.
You understand
I
that?
understand.
What you have on the screen right now?
Yeah, okay. But you don't understand how it applies to this.
No.
Okay, so
I feel the same.
okay, so the first thing is here, all right? Where are we? The true. So the true, this applies to what? Y equals x plus 1. That is this particular graph here. Would you agree? That's y equals x plus
Please.
1. Now, when we got the true, right? The true applies to um this point, the origin. And so since this point, the origin, is true, that means everything on the side of the origin is true for this particular line. So that's why we shade the red on this side, all right, to the right of that line, because the point 0, 0 is true. And so that means that all of this is true, all right. Next up is we find that when we go to y is greater than or equal to 1 minus x, that's false. So that means that when we look at this line, y is equal to 1 minus x, the origin is no longer true. The origin is false. And so since the origin is false, we don't want the false region. We're going to shade the opposite way. All right. So we shade in the opposite way from the test point 0, 0. And then finally, we have y is greater than or equal to 0. That just basically means all of the y-axis but the positive side. All right. All right. Okay, so let's move on. Hopefully that's a little bit clearer. Um, I guess next week we could come back and explain some more. Okay, so that brings us to the end of math for the week. Please send in the notes for me, please, before you leave. And if you have to go, you can leave now. This is only for those people who are not doing who are not doing religion and family life. Sorry, religion and social studies, not family life. Okay? If you're doing RK and social, please stay. If you're not doing that, you are free to leave.
Excuse me, Mr. D.
Yeah,
Um, let me back this. What I had problems with you free after class.
after class, after class. Oh my, boy, no, I'm not available after class. I say that because I barely keeping my eyes open in class though. Um, so yeah, I can't make that. I can't make that after class. Um, I'll look at it though, cause I didn't even look at it. That's the thing. So I can look at it and see if I could answer it readily. If you don't receive no answer from me on Friday, then um message me again on Sunday.
Okay.
Yeah. All right. So all right. So that's continuous. This is number. This is we're gonna do social studies first, right? Right.
Yes, sir.
Yes, sir.
Right. So right. Um, can someone give me a quick summary on what we did
Yes, sir.
last week on in social studies? A quick overview. We've come into a really important event. At least he's talking about a really important event. This event involves change and new and
Renaissance period.
yeah, Renaissance, right? Um, uh, but where did the Renaissance come along in our discussion though? Like, of things. Like, how does the Renaissance fit in our discussion?
When he's talking about how was the voyages possible,
Yes, very good, Mr. Cooper. So there's a bunch of voyages that happened. We talk about the motivations of those voyages and what was the motivation, if you can remember, of those voyages.
people want to get rich, right?
They want to get rich, and what else?
To find more um land.
Yeah, they want to get rich and famous, right? Um,
They wanted to convert.
they want to what?
They wanted to convert natives.
Yeah, they wanted to convert the natives. And who would that please?
Okay. The Pope.
That would please the Pope, right? Um, all right. So, okay, what else we learned from that? So we began talking about what made the voyages possible, and then the first thing we talked about was the Silk Route, and that helped to make the voyage possible. But the main thing that really, you know, um, you know, helped to make the voyages possible was the Renaissance. And um, okay, let me just move this because I have the answers right there. Um, so the Renaissance, can someone define it for me? Like,
Rebirth in learning.
say it again.
The rebirth in learning or knowledge.
Okay, rebirth and knowledge, learning, and okay. So why is it called rebirth though? Like, because re means you did it before. So why they call it Renaissance? Why did they just call it new one time? Like, why re?
Because I feel because they probably um um did like the same thing they already did, but like better or more advanced.
Ah, very good. Because remember, with the Renaissance, it wasn't an entirely new um idea, right? They borrowed some ideas from who?
The people who already was there.
Yeah, but through what? Through groups of people they borrowed ideas from. One start with G, other one start with R.
Roman?
Romans, yes. And then who else? So they borrowed some
Greek?
the Greeks, yes. So the Greeks
Greek.
and the Greeks. So the Greeks and the Romans um had invested time and effort in literature and art and science and stuff. And they left a wealth of information. And what the Renaissance basically was looking back at that information and building from it. All right. Now before the Renaissance occurred, this revival of of knowledge and science and stuff like that. Um, Before that happened, there was a period where little to no scientific invention was um, did happen. What do we call that period?
Arcades?
The Dark Ages, or as the notes said, start with
The
M,
Middle Ages.
the Middle Ages, right? Good. So why didn't scientific exploration happen during the Middle Ages?
Because there's like ecstatic from 200 years.
It was
The ideas is
yeah, so it did.
right.
It was static, but why was it static? Why there wasn't why was there a pause in scientific inquiry and learning
The
exploration?
churches.
Because the church what?
All frighten them not to travel because they're single.
The church did something. What did the church do? Did we get into that?
No, so
Discourage the people.
We had to. Yes, they're right there in front of me. So it says during this time, ideas were generally stagnant, and the populations of Europe achieved very little in science and in invention. Why? Because the church was very powerful. It rejected and suppressed ideas that might threaten its own power. It believed that people should accept its teachings no matter what, and people were discouraged to think for themselves in case ideas spread that would stop them from devoting their allegiance to the church. Okay, you understand now?
So the
who knows
church.
Go ahead.
who know the church was that evil?
Uh, well, here they're not talking about um churches at large. They're talking about a specific church, which was the Roman Catholic Church at that time. They were the one. They the ones pulling the horses, right? They had great power during that time, and you know, if you were a little chip on the block, you had to listen to what they say, or else you would face severe consequences. Because people
Yeah,
really
kill you from money.
Because people, even I don't care if you was the king, I don't care if you was a big scientist, I don't care if your mommy is wealthy, you better listen to them, or else they would see to it that you undergo a lot of persecution and, death, and, you know, it'll make your life live in hell, you know. You would wish to die, right? Um, yeah, so that's why there wasn't a lot of scientific inquiry at that time. They're like, boy, I ain't really trying to, I ain't really trying to march no one for, and I ain't really trying to go against what the church say, because once you go against what the church say, you know, it just having problems. But, this people, um, but the people eventually overcame that, through different, reasons, and then scientific inquiry, the revival began. All right. Um, okay, so let's see. All right, so let's continue. So from where we stop. So we're gonna talk about the superstitious ideas that the church had a play in that caused scientific inquiry to be at a standstill, right? So what ideas um you know caused them to not to venture into exploration. So
That the earth was flat.
it was flat, yes. So for example, we continue from where we left off. So for example, in the 3rd century BC, the Greeks thought that the earth was round. As in the 3rd century, the Greeks thought that the earth was round. But almost 12 centuries later, the church was influencing the production of maps of a flat world map. So even years after the Greeks said, "Hey, guess what? The earth is round." We still have them, the church still holding on to the belief that the earth is flat, and still spending lots and lots of money to produce maps that are false. It's that present the earth as flat. Okay. And of course it did work because they had the money to do it. They had the money to do it. Anyway, the church. Any questions before I move on?
That was weird.
Yeah. The church also encouraged belief in mythical beasts and monsters. So the church also encouraged belief in mythical beasts and monsters, implying, sorry, that any country beyond the reach of the church was populated by frightening creatures. So the idea is that, hey, they're saying, hey, um, the earth is flat, and if you be daring to try and go over it, you'll be met with frightening creatures and monsters and mythical beings. So that was the trap that they had the people in. Okay. All right. Do we understand now?
Yes, sir. That was like the only two.
We finished. Man, we finished yet. However, however, that's only two that the book mentioned, at least right at this juncture. However, by the end of the 15th century, the church itself he was beginning to experience quarrel about its teachings. Now that's called what was happening was the Reformation was happening. Reformation, we call that. Reformation was basically a religious movement to basically tear down the lies that the Catholic Church has been making as it relates to the Bible. So this one is talking about how the lies that they make concerning sailing and science, but there were lies that they had concerning the Bible, and Reformation began to happen about that. So, however, by the end of the 15th century, the church itself was beginning to experience part about its teaching. That's the Reformation. It could not prevent all right, it could not, sorry, the church could not prevent um, the new discoveries of the old knowledge becoming more and more widespread. So it could not prevent the new discoveries of the old knowledge becoming more and more widespread. Now, what did the Renaissance do? The Renaissance, well, that's wrong. The Renaissance brought a new emphasis on the individual, on the individual, and on a new desire, sorry, and a new desire to find out the will. So the church had its influence on the people and on what they believe. But as we go closer and closer and closer, we see that some of these teachings are not right. They are, they're laughable, and you see that the Catholic Church did many things to keep people believing this error, right? But then sooner or later, it just became too much, and the person just became aware and aware, and so they couldn't keep the people back. Okay. Any questions on this?
No, sir.
No. Sure, straightforward.
Yeah.
All right. So next week we need to talk about the actual things that was made. The maps, the instruments, the ships, the hourglass, the throwing lead, all those stuff. We're gonna look at and see how they actually help assist in the voyage.
What's your tea?
Yes.
The flat world map. That's the maps we still like use nowadays. For
No,
the
no, 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 no. What we have now is a map of the world, but it's even though it's flat, it doesn't. It's still trying to show a spherical world, right?
so they almost different.
But that one was different. Just everything flat, and you can't go over. You can't explore a certain point because if you go and explore it, you will get eaten by monsters. Yeah. All right.
I didn't know there was monsters in the ocean.
It's just this. It's called a deception. Like doesn't matter. All right. Okay. So the last thing we did was um in RK was the calling of the 12. Jesus chose his 12 disciples. Um, talk about why he chose disciples and talk about the 12 disciples that he had. Um, I don't want to be long with this one because I am really out of it, people. The
I can
bishop,
see that.
you see that?
Like you've been yawning all night.
Boy, problem is I went to bed at 3 o'clock last night. That's the problem.
Wow.
What you was doing?
I don't know.
Um, work.
Hmm.
So yeah, yeah. Mr. Petit have a lot of work to do, you know. So I was working on answer keys to past papers. Um,
Wow.
so but then I had to go sleep. And and then after I slept for about an hour, then I wake up at 4 again. So boy, it's been rough. So it's telling, man. I didn't know it was gonna be that bad. So
That was me in class today. I couldn't stop yawning, but I gone to sleep.
yeah. Um. So uh, we have several good topics. I don't wanna do them tonight because they are nice topics, and I don't wanna waste that. But we should though. We should look at the call of Levi. Let's do that. The call of Levi. This one should be pretty simple. The call of Levi. Jesus calls Levi. So, um, so Levi was. Anyone know a Levi? Anyone named Levi? Like in real life? You have
You
anyone
know, some
who will say to you, or is it a boy or girl?
boy.
All right, that's good.
Um,
Anyone know a Levi? No one.
You rarely see them in the Bahamas.
You
I
rarely
just
see.
realized.
That's interesting. I have a friend named Levi, and what's interesting is that just the day he hailed me, so it's. I'll definitely tell him that today we did the call of Levi in class. So the
That's
scripture,
the guy.
say it again.
That's the guy who's still mad that he didn't give me no answers.
No, 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 no. I used to remember that story. All right. So Levi was the fifth um person. Jesus called to be a disciple. Okay. Um, he was otherwise known as Matthew. Okay. Now, when Jesus called him, he was working as a what?
Tax collector, I think.
Tax collector, yes. Now, Levi left his job to follow Jesus. He turned back. He turned his back, sorry, on the power and the money that comes from being a tax collector. What was the job of the tax collector?
Collect the money from the
Taxes from the
people.
people for the Romans.
Yeah, good. Did the Jews like tax collectors?
Oh, they
No,
hated them. No.
they used to rob the people and charge them more than needed.
Yes. Very good. So the Jews didn't like tax collectors. Number one, because the tax collector um was a Jew who was collecting funds for the Romans. So they felt like they was what?
Stealing.
No. I mean that too, but they felt that they was traitors, right?
Busy.
Yeah.
You have his back.
Okay, he turned his back on. So tax collector is someone who collects money from the people, from people, for the government. For the government. Now the Jews hated tax collectors because they often felt that the tax collectors made them pay more than they were supposed to. That's the first thing. They were also so they thought that the tax collectors, was actually robbing them, right? Because you can imagine if the government say they only want 1 penny and the tax collectors charge $5, right? How much how much more money you see that they getting? See?
A lot more.
A lot more, right? So that's how Zacchaeus got rich too. He used to overcharge the people.
What's the one? Okay.
And they also seen as traders because they go on and take money from their own people on behalf of a Roman government, which the Jews hated with a passion.
You can't judge them. You gotta do what you gotta do.
Well, they didn't like that.
I wouldn't either.
You wouldn't either. Yeah, I mean, it just feels
I
weird.
can't buy one penny. I ain't paying no $5.
Well, how you know if the tax collector is the one who who telling you what you're gonna pay? So you better listen to
That
them.
could be true.
Sorry, give me one moment. Yeah. So okay. So Jesus Jesus actually ate at his home. So Jesus eats at Levi's home. So give me one moment. Mhm. Mhm. Yeah. It over yet? All right. Okay. So yeah. So later that evening, all right. Later that evening, Levi held a dinner party for Jesus and the other disciples. He also invited some of his friends.
Mr. Petit,
Uh,
when they had the dinners, only Levi and the other four, or
I tell you now, he also invited some of his friends who were tax collectors as well and outcasts. Because if you're a tax collector, you're outcast. You know what I mean by outcast, right?
I heard the term before, Mr. Petit.
Yeah, outcast mean that no one wants you. They so we gonna finish off the notes from for tonight on next week. But basically, the Pharisees didn't like Jesus eating with Levi. All right. Um, they felt that Jesus shouldn't be um, you know, Jesus shouldn't be associating himself with them with with tax collectors. But Jesus um told them that hey, I came to bring the message to everyone, not only a certain group of people. And I think that's the same message for us. Like we shouldn't only um we shouldn't only think about one class of people, but everyone is deserving of love and care and attention. So yeah, I'll leave it at that. So let me know if you finish writing so we could
Good night.
call it a night. Who's this coming at this time? Okay. Alright. And send a note to me, please.
Oh, this man again.
Yeah.
I went in the Bluetooth.
Well, at least we'll go to over so. Where are we?
Good night.
Are you done? Well, have a wonderful night. You have notes? Still writing?
Yes, I done.
Okay, that's good. Please send in the notes for me, please.
Uh,
Alright, have a good one.